Hello everyone, welcome back to Edexcel Science Channel, and now we are at question 2 from 2026 June IAL Physics Unit 3 paper from Edexcel. So question number 2 is saying, a student investigated the energy stored in a rubber band. She attached the rubber band to a length of string and a mass holder as shown. So this is basically two things that is holding the rubber band, and the rubber band is attached to the string, which has a mass holder at the end. Okay. The student placed a mark on the bench vertically below the point where the rubber band was attached to the string. So maybe right over here, like uh, where just below the boundary of the rubber band and the string. She then added a mass to the mass holder and placed another mark on the bench. Identify a health and safety issue with this investigation and how this issue may be dealt with. So what they're basically doing over here, guys, is that they have basically attached the rubber band between these two blocks, and they have attached the rubber band with this string, and the string has a mass holder at the end. They are going to increase the mass gradually, and that is going to pull the rubber band even more, right? It is going to stretch the rubber band. So they are going to put crosses right where the rubber band is. So now they're asking us, what is identify a health and safety issue and how this may be dealt with. So the one that immediately comes to my mind is that we have all played with rubber bands. We have basically put rubber bands between our fingers. Very bad drawing, I know, guys. So maybe this is a rubber band and you were pulling, and then suddenly they come out and hit us, right? So this rubber band might snap and hit somebody's face or eyes, right? So the first is that rubber band might snap and hit student's eye. And the way to solve this issue is by wearing goggles, okay? You can say goggles or you can say eye protection, both are fine. So this is one set of answer. Another set of answer that you may write is that this mass holder is attached to the string. If you increase the mass, it might fall and hit somebody's foot, right? So the mass may fall and hit student's foot. Okay. So the way to solve this issue is that um wear safety boots. I feel like this type of questions are very logical. Like the answers are like literally in the diagram. But some students do find it difficult to answer this type of questions. They can't simply, you know, come up with an issue or a suggestion. I just suggest that practice a lot of past papers and you will understand the pattern in this type of questions. Moving on, the student used a digital caliper to measure distance x between the two marks. The photograph shows the reading on the digital caliper. So this is the reading, guys. Determine the percentage uncertainty in this reading. So the first of all, to find out percentage uncertainty, we need to find out absolute uncertainty. But to find out absolute uncertainty, we need to find out the resolution of the instrument. The resolution of this instrument is 0.01. Okay, it's going to take measurements mostly up to 2 decimal places. So the resolution is 0.01. So the resolution is 0.01 millimeters. That means that the absolute uncertainty is going to be half of the resolution, right? It's always half, guys. So that is going to give you 0. I think 0.005, yeah, 0.005 millimeters. Now that I know the absolute uncertainty, now I can find out percentage uncertainty, which is absolute uncertainty divided by the measured value times 100, which is going to give you 0.023 percentage. Okay. All right. Explain two techniques she should use to reduce error when measuring X. Okay. So since this is a digital meter, it might be prone to zero error. Okay. So my first answer is going to be that check for zero errors before using the caliper. Why? To reduce systematic error. So systematic error is basically an error that is going to have the same effect, the same error on the values. Okay. So if let's say that this has a zero error, it's always going to increase the reading from the original value, the true value. So this is called a systematic error. Another thing that we want to fix is that um, let's say that you have the 2 marks right over here. You are taking one measurement from the edge to another edge, let's say. You are taking another reading from this far, from the other end to, let's say, this end. Okay. And you are taking another from the center to the center. So you see, all these different measurements will be very close to each other, but they will never be the same. So you need to have a convention basically, which is that either you always take from this side till this side, or center to center, or from this side till this side. But let's not make it too confusing. Always make sure that you take from center to center, okay? So that you do not have random errors. Random errors are basically errors that will either increase or decrease the reading from the true value, from the original value. So what I'm going to write is that measure from center of the marks to reduce random errors. Okay. So moving on. Question number B. The student repeated the experiment and recorded the following values of X. Determine the mean value of X. So the mean value of X is basically, I have to add all the values and divide it by the total number of values. And that is going to give me 22.38, which is basically 22.4. I want to take the mean value at the same accuracy as these values. Okay, I could have taken 0.38, but since all these values are taken at 1 decimal place, it is better that if I round up. So the mean value is 22.4 millimeters. Determine the percentage uncertainty in the mean value. So when you have multiple readings, the way we find percentage uncertainty is by finding out the range. Okay, the first thing we need to do is to find out the range which is the max value minus the minimum value. The maximum value over here is 22.6, and the minimum value of this data is 22.1, which is going to give us 0.5 millimeters. Then you have to find out your uncertainty. So my uncertainty is always going to be half of my range. So 0.5 divided by 2, so it becomes 0.25 millimeters. Now I can find out my percentage uncertainty, which is 0.25 over my mean value times 100. That is going to give us 1.12%. 1.12%. Okay. This method is always the same. You have to find out range, then half of the range, and then percentage uncertainty. Okay. Moving on to question number C, guys. The student calculated the combined weight of the mass and the mass holder. She determined the combined weight and mean value of X for a range of masses. She plotted her results on a graph as shown. Determine the energy stored in the rubber band when the weight is 8 newtons. Okay. So since they're asking us only till 8 newtons, I am going to find out the corresponding point on the graph at 8 newtons, and then I'm going to draw a straight line till the x-axis. So what we have to do to find out the area, to find out the energy stored, is that we have to find out the area under the graph. Okay, so we have to basically find out this area. Now, we know that to find out the area accurately, we have to use the integration, but we do not have integration in our physics syllabus. So we have to find out the area manually. The way I like to do it, and which always gives a very close value to the marking scheme value, is that I'm going to find out the area of one square only, first of all. Okay. So according to the graph, 1 unit in the x-axis is 0.01 and 1 unit in the y-axis is 1. So I can say that energy for 1 square is 0.01 times 1, which is basically 0.01. Next, what I am going to do is I am going to count the number of complete squares and incomplete squares. Okay, and you will see in a minute why. So let's count the number of complete squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice, guys, how I have taken this as 7, even though it is not a complete square. Some portion of it is above the graph. However, you have to keep in mind that this is an approximation. So if you take that as 7, it's fine. Okay, but don't take this one as a complete square because it's literally in half. So 9, 10, 11, 12, 13, 14, and 15. So the number of complete squares that I have is 15. Now let's count the number of incomplete squares. 1, 2, 3, 4, 5, 6, and 7, and 8. So incomplete squares, I have 8, but let's actually count it as 6, I suppose, because this one and this one and this one, they basically add up to 1 square, kind of. So again, round off, okay? You need to be on your feet. Now, what I am going to do is to find out the energy, the total energy, I am going to multiply the area of 1 square with the total number of complete squares. And then I'm going to multiply the area of one square with the number of incomplete square, but I'm going to multiply a half with it. This half is for approximation. Okay. This is to make up for the fact that this graph is half, kind of, this graph is half, this graph is also half, this graph is also half. But even if it is not half, we always multiply a half to basically approximate, because we cannot take the whole thing because all these graphs are incomplete squares. This should give you a value in the range of 0.18 to 0.2 joules. Okay, and that is it for this video, guys. Please don't forget to like and subscribe to the channel. I hope the explanation made things easier for you guys, and I will see you in the next video.